All right, so today we're going to be talking about parallel and perpendicular lines. And I guess in order to talk about them, we got to first know what they are. I think most of you do know, but let's cover it anyway just to make sure. So, parallel lines. Well, if you think back to when you first learned this in geometry, I'm sure that you could figure that parallel lines are lines that don't intersect. Um, Basically, they're lines that maintain a constant distance apart, right? So they're going to maintain a constant distance. Okay, and if you remember, we're working on slope right now, and the important thing to get out of parallel lines when we're working on slope is that for lines to be parallel, they must have the same slope. So that's the real pivotal piece right here. So we're dealing with same slope. Now, they're going to have different y-intercepts. Otherwise, you'd be talking about the same line or a line right on top of itself. So we need to have the same slope, and we want to have different y-intercepts. Okay, so we're just going to call that different intercepts. Okay, we're going to concentrate on parallel lines first, but let's talk about perpendicular lines as long as we're here. Perpendicular lines are lines that intersect, okay, and when they intersect, they actually form right angles. Okay, so they're going to make 90-degree angles. Again, right angle is 90 degrees. They're going to make right angles when they intersect. All right, but we're going to concentrate first on parallel lines, and then we'll talk about how slope plays in with perpendicular lines. So let's take a look. Here's an example of a problem that is very typical for a parallel line problem. You want to write the equation of a line that passes through the point 2, 3, and is parallel to the line y equals 1/2 x minus 4. So we go back to what we just learned previously, that parallel lines have the same slope. So what that tells us is our new line, the line we're going to write the equation of, has to have the same slope as the line that we're dealing with here. So it means our slope is going to be 1/2. We also know that we're passing through the point 2, 3. So if we're going to write the equation of a line that passes through that point, we're going to use, well, we can use one of two different types of equations. I guess we'll do it both ways, and you pick which one you like. So we'll start off with using point slope, because the reason it's called point slope is because we have a point and we know the slope. So point slope lends itself to writing this equation. So let's do that. If you remember your point slope equation, that's going to be y minus y naught, or y0, is equal to the slope times x minus x sub 0. And we know that this is our x sub 0 here. We know this is our y sub 0 here. And we know obviously what our slope is. So to write the equation, all we're going to do is substitute in. So we have y minus, in this case, it's going to be 3, is equal to the slope, which is 1/2, and x minus 2. So technically, right now, we've completed the problem. We've done exactly what we were asked to do. We wrote the equation of a line that passes through the point 2, 3 and is parallel to the line y equals 1/2 x minus 4. Many times you're going to be asked to write that equation in slope-intercept form. So if you remember from when we did our conversions, this is a very easy one to convert into slope-intercept form. So the first thing we would do is we're going to distribute, not substitute. We already did that. So it's going to be y minus 3 is equal to 1/2 x and minus 1. Again, distributing the half to the negative 2. And then to get it in slope-intercept form, we would just add 3 to both sides. So we have y is equal to 1/2 x plus 2. And that's going to be the equation of a line that's parallel to this line and passes through the point 2, 3. Now, we did this in point slope form. You can do this in slope-intercept form. And let's do it in slope-intercept form so you can see what that looks like. intercept form, we would just write our generic equation for slope-intercept, which is y is equal to mx plus b. And then what we're going to do from there is we're going to substitute in. Well, we know x, right? This is our x over here. We know y, and we know m. And then we'll figure out what b is. So y is going to be 3, and that's equal to the slope, which is 1/2, x, which is 2, plus b. So that means 3 is equal to, well, half of 2 is 1, plus b. Subtract 1 from both sides, and we find out that b is equal to 2. So our equation is going to be y equals our slope 1/2, x, and then our y-intercept, our b, is plus 2, which is the same thing we got when we did it in the other form. So as you can see, either form is okay, either way you want to do it. It doesn't matter, it's up to you. Okay, let's do one more example. We're going to write the equation of the line that's parallel to the line y equals -3x plus 7 and passes through the point 1, -4. So again, you pick your choice, whichever way you like to do it. I just find it easier to write the equation in point slope form, so that's the way I'm going to do it. But like I showed you on the last example, you can do it in slope intercept form as well. So we're going to write our point slope equation. So that's going to be our y minus y0 is equal to slope m times x minus x0. All right, now you can pause the video here and substitute in, and I'll substitute in, and we'll see if you have it right. So pause it now. All right, so this is going to be y and then minus -4. We'll fix that in a second. Our slope is going to be -3, and it's going to be x minus 1. And we'll clean that up and make it y plus 4 equals -3x, 3 times x minus 1. So there's our equation, and it's written in this case, it's written in point slope form. Very easy to put it in slope intercept form, which we're going to do. So here we go. Y plus 4 equals -3x plus 3. Then we would subtract 4 from both sides, giving us y is equal to -3x minus 1. So that's going to be the equation of the line that's parallel to y equals -3x plus 7 and passes through the point 1, -4. And that's how you do parallel line problems. All right, stay tuned. We're going to do some perpendicular line problems. The first slide we did, we talked about perpendicular lines, and we know that they form right angles. But perpendicular lines have to have opposite reciprocal slopes, okay? And here's why. When you look at this, okay, and we have a line, let's say that we have this line, okay? And that line is, let's say y is equal to, again, we're just going to kind of estimate this a little bit. Let's say y is equal to 3/2 x plus 3. Okay, so the slope of this line is 3/2, and that kind of makes sense. You can kind of see that that slope would be about 3/2, right? But if we want a perpendicular line, our perpendicular line to this one is going to have to go in this direction. Now, it doesn't have to be right there. I mean, it could be over here, right? It could be over here. We don't know, but we know it has to go in that direction. So if our slope for this first one was a positive 3/2, you should be able to see that the slope of a perpendicular line has to be negative, right? That would make sense. So the fact that they have opposite, which would mean the negative, the opposite sign, reciprocal slopes, the reciprocal just means that instead of rise over run, you're going to do run or rise, so to speak. So we would take the slope of these lines, the red lines that we have here, the slope of all of those lines is going to be negative 2/3. And I know the graph doesn't look like that, but that's probably what it would come out to be. Or that's definitely what's going to come out to be mathematically. But hopefully my picture does it a little bit of justice. So let's see if we can create a problem like we did before. And we'll use this equation here on our next slide. Here's our perpendicular problem. So we're going to write the equation of line perpendicular to y equals 3/2 x plus 3 and passes through to point 6, 2. Well, like we just talked about, the perpendicular line is going to have a slope that's opposite and reciprocal. So because this slope that we know is 3/2, the perpendicular slope is going to be negative 2/3. So now we know the slope. Our slope for our new line is going to be negative 2/3. We have a point, and now it's just like the problems we did before with parallel. So again, I'm going to use point slope form. You can do it in either form. So it's going to be y minus y0 equals the slope times x minus x0. So we have y minus 2 is equal to our slope, which is negative 2/3. And that's going to be x, in this case, minus 6. So again, we've now satisfied the condition. We wrote the equation. But if you're asked to write it in slope-intercept form, which is going to be the norm, we're going to say, so this is y minus 2 is equal to negative 2/3 x. And then we have a negative times a negative is going to be a positive. And 2/3 of 6 is 4. So now all we have to do is move the 2. So we'll add 2 to both sides. So y is going to be equal to negative 2/3 x plus 6. And that line is going to be perpendicular to this line every time. Okay, so thank you guys for watching. I hope that